Howdy, Mr. Sutton here with the Pre-Cal Honors 2-3 Extra Practice Number 2 solutions on Rational Roots Theorem. For this one, we are trying to find the complex zeros for this quartic fourth degree polynomial. So we have to do the Rational Roots Theorem at some point on this one. But one thing we can do before we even go that far, if you notice we have an x in every single term here, that means we can factor an x out of everything. That'll at least make our lives a little bit easier down the road. So factoring an x out, we're now left inside with x to the third minus 3x squared minus 53x minus 9. All right, so next thing we're going to do is we're going to take a look at this inner polynomial and come up with a list of possible rational roots. Those will be factors of our constant, -9, divided by factors of our lead coefficient, which is just 1. So it's really just going to be the factors of -9 then. So those are going to be plus or minus 1, 3, and 9. That's it. So that's just 6 different things. We're going to try up to 6 of those things in our calculators just to see what gives us 0 when we plug them into this inside polynomial. And by the way, I mean, we could plug these into the outer polynomial as well, this whole polynomial, but either way, it should give us 0 if it's one of the roots of f of x. So let's go to the calculator. So here I am on the calculator. I'm going to go to y equals, and in y1, I'm going to put this x cubed piece inside, and I'll just do that off camera right now. So I've got this entered in y1. I'm going to go to second window, and I'm just going to make sure that independent is set to ask. That's going to allow me, when I go to second graph, to table, to just plug in whatever x values I feel like and get the results from plugging them into this function. So let's start with 1. I always like to start with 1. That gives us something that's not 0, so we keep going. Let's try -1. That gives us still not 0. What was our next number? We had 3, right? Positive 3. That gives us -168. Let's try -3. We're looking for 0 here. Still not 0. That's 96 if I plug in -3. Okay, it's down to 9 and -9. We're hoping one of these works. So I try 9, and we finally get 0 out of that. So 1 didn't work, neither did -1 or 3 or -3, but 9, we see f of 9 was 0. That means that I can use 9 with synthetic division on this x cubed part of this here to break this down a little bit further. So let me set up my coefficients for synthetic division, and again, I'm just doing this on the x cubed piece. We don't need to do the original polynomial anymore. So we've got 1 for the 1x cubed minus 3, -53, and -9. And my box number I'm using is 9. So let me bring down the 1. Times 9 gives me 9, plus -3 gives me 6, times 9 gives me 54, plus -53 gives me 1, times 9 gives me 9, plus -9 gives me 0. So we've got a couple factors. We have the x that we took out in the beginning. We now have x minus 9, the box number that gave us 0 here. And we have this quotient. This is a 1x squared because we started with x cubed, so 1x squared plus 6x plus 1. I probably can't factor this. I mean, I would need numbers that multiply to 1 and add up to 6, so that's not going to work. But I can use quadratic formula to find the zeros from this quadratic right here. So we'll have -b, that's -6, plus or minus the square root of b squared, so 6 squared, minus 4 times the a value 1, we have an invisible 1 next to the x squared, times the c value of 1, all over 2 times the a value of 1. Simplifying that, we have a -6 out there. Inside, we've got 36 minus 4, which is 32. And then we have a 2 downstairs. Now, square root of 32 can be simplified a bit. We can split that into 16 times 2. And the square root of 16 is 4. So this is -6 plus or minus 4 root 2 over 2. And I can go a little bit further on that, but let me start writing answers at this point. So we have x equals 0 for this x out in front, x equals 9 for this factor that we got, and now we've got -6 plus or minus 4 radical 2 over 2, but I can reduce that, dividing both of these by 2, to -3 plus or minus 2 radical 2. And this gives me my 4 answers that I would expect for this 4th degree polynomial. On this problem, we're trying to solve for the complex zeros of this quintic 5th degree polynomial and show the possible rational roots list as well. So because we have 5th degree, we're expecting a total of 5 complex answers. So let's go ahead and find those. I can start before I even get my PRR list by factoring an x out of all of these. So let me do that to make my life a little bit easier. So that'll give me an x to the 4th minus 6x squared plus 8x. And if you're paying close attention here, you might notice that the stuff inside is in quadratic form. We could actually factor this into x squared minus 2 and x squared minus 4. And that would make this a much faster problem. But if you didn't realize that, that's okay. They said to show the PRR list anyway, so we need to do that to satisfy the problem. So our rational roots, our possible roots, those are going to be factors of this constant 8 divided by factors of the lead coefficient, which is 1 in this case. Since the lead coefficient is 1 and we're dividing by 1, it's really just the factors of 8 that are making a difference here. So that's going to be 1, 2, 4 goes into 8, as does 8. So those are our 8 different possible roots. Let's go ahead now and I'm just going to show the synthetic division kind of solution to this. But again, you could have already factored this and done it that way. So I'm going to plug these possible roots into my calculator. I'm just going to do x to the 4th minus 6x squared plus 8 on the calculator. Although I could use the entire polynomial, doesn't really matter. Let me go to the calculator now. So on my calculator, I'm going to y equals, and I'm going to put in this 4th degree piece of my polynomial in as y1. I'll just do that off camera. Now that I've got that entered in, let me go to second window and just make sure that my independent is set to ask, so that when I go to second graph table, I can just ask it to give me the values for specific x values. I can just plug the x values in here. Let's start with 1. That gives me an output of 3. I want 0 though, so let me keep going. Let's try -1. That gives me 3 as well. Interesting. All right, next number on the list is 2. Let's try +2. That gives me 0. So f of 1 and -1 didn't help us, but f of 2 gives us 0. So I'm going to use synthetic division with 2 as my box number on this 4th degree piece here, and hopefully that'll let me break this down a little bit more. So we've got coefficients of 1 for the 1x to the 4th. We have a placeholder 0 for the missing x cubed that should be in there, so be careful with that. We have -6 to take the place of the x squared term. We have another 0 to hold the place of the missing x term. And then we have the constant 8. And again, I'm using a box number of 2 for this one. So we bring down the 1, times 2 is 2, plus 0 is 2, times 2 is 4, plus -6 is -2, times 2 is -4, plus 0 is -4, times 2 is -8, plus 8 is 0, which is what we were hoping for since we got 0 when we plugged 2 in the other way. So that means I can break this up into the x that I initially took out, x minus the box number, x minus the 2 that I just plugged in, and this whole quotient here, which is going to be 1x cubed, because we started with x to the 4th, plus 2x squared minus 2x minus 4. And we'll set all of that equal to 0 at this point, because we're trying to find the zeros. Now, you could use synthetic division again to try to break down this 3rd degree polynomial, and then you would be using possible roots of 1, 2, and 4, because we're down to a 4 for that constant. But there's a little bit of a faster way. You might notice that we have a 1-to-2 ratio for the first 2 coefficients, and a -2 to -4, which reduces to a 1-to-2 ratio for the second ones. So we can actually use factoring by grouping on the stuff inside here. So we have the x minus 2, and now I can take an x squared out of these first 2 terms in here, leaving me with x plus 2 in the parentheses. For these next 2 terms, I can take out a -2, leaving me also with an x plus 2 inside. So fully factoring this, I've got the x, I've got this x minus 2. In here now, I can take out this x plus 2 as a common factor, and I'm left with an x squared minus 2 as my final factor. Going through and setting each of these equal to 0 and solving, starting with x here, I've got x equals 0, 2, and negative 2, so I'm going to write plus or minus 2 for that. And then for this x squared minus 2, if I add 2 to the other side and square root both sides, I will get plus or minus the square root of 2 for my final two solutions. So this is a total of 5 solutions, which is what we would expect for a 5th degree polynomial. For this problem, I'm trying to solve for the complex zeros of this 4th degree polynomial. So let me start by getting my PRR, my rational roots list, possible rational roots, and then we'll hopefully be able to use some of those to get zeros and use synthetic division to break this thing down a little further. So our rational roots, possible ones, are going to be factors of my constant 8 divided by factors of my lead coefficient 1. So really just factors of 8 then, which are going to be 1, 2 goes into 8, along with 4 and 8. So I'm going to plug these in one at a time on my calculator until I get a 0, and then I'll use synthetic division to break things down further. Let me go to the calculator now. So on my calculator, I'm going to go to y equals, and I'm going to put in y1 this whole 4th degree polynomial. I'll do that off camera just to save some time here. There we go. I've entered that whole polynomial into my y1. Now let me go to second window just to make sure that independent is set to ask. So that way I can plug in any x values I want when I go to the table here, second graph. So let me just start plugging in x values to f of x until we get something that comes out to 0. So my possible roots, let me just move the calculator so we can see a little bit better here. We had 1, 2, 4, and 8, positive and negative versions of those. Let's try 1 first. And that does not give us 0, so let's try negative 1. That gives us negative 6. Let's try the next one, 2. Gives us 312, not what we wanted. How about negative 2? Now that gives us 0 when we plug it in. So that means that when I plug in negative 2 using synthetic division, I'm going to be able to split this thing up further because I'm going to get a remainder of 0. So let me write out my coefficients for synthetic division. We've got 1 for the x4th, and this was just all the things we tried on our calculator. Again, f of negative 2 was the magic number. So we've got 1 for the x to the 4th, 10 for the x cubed, then 33, 38, and 8. Box number of negative 2. So we bring down that 1 times negative 2 is negative 2, plus 10 is 8, times negative 2 is negative 16, plus 33 is 17, times negative 2 is negative 34, plus 38 is 4, times negative 2 is negative 8, so that's a grand total of 0, which is what we were hoping for. So I can now split this polynomial up into x minus negative 2, or x plus 2, times this whole quotient here. So this 1 is really 1x cubed, because I started with x to the 4th, and it's always 1 lower than we started with. So 1x cubed plus 8x squared plus 17x plus 4. And at this point, we're going to go to the next slide and break this thing down a little bit further. So here's where we left off on the last slide. We were trying to split this thing up and find the complex zeros. So let me go ahead and just generate a new list of possible rational roots because I've got a smaller polynomial now. Now my constant is 4 instead of 8. So now the only things I have to try are plus or minus 1, 2, and 4, not 8. So let me go ahead and try those in my calculator. Now when I do this, I'm only going to try things in this x cubed piece of it, which I'm going to call g of x from now on, just so I don't have to keep saying this x cubed thing. So g of x is just this smaller piece of the original f of x polynomial. And I'm just going to use this so that when I test out my root of negative 2 again, I'll figure out if it gives me another 0 and not just repeating the work I did earlier from this x plus 2. So let me go back to the calculator. So here's our calculator. We're going to y equals, and let me just move so I can see here. I'm going to now put in my y2, I'm going to enter this x cubed g of x polynomial. Great, now I've got that g of x entered in y2. Now I'm going to do second graph to go back to table. And notice that my calculator has already plugged in positive and negative 1 and 2 to this new g of x piece of my whole polynomial. And none of those results give us 0. So we move on then to the next thing on our list, which was positive and negative 4. Let me go down here and plug 4 in to see what happens. That does not give us 0 for either of those. Let me plug in negative 4. This is the last number on my list. So we're really hopeful that this works. And it does. We get 0. Awesome. So I would have had to try out negative 2 again, because if it works once, it could work again. It didn't, so I tried out 4. That didn't work. Negative 4 did work, and I show this here so that people know why we were using negative 4 in synthetic division. So that's what we're going to do now. Use synthetic division on g of x with negative 4 as the box number. So I've got my coefficients of 1 for the x cubed, 8, 17, and 4. Box number of negative 4 this time around. We bring down the 1 times negative 4 is negative 4, plus 8 is 4, times negative 4 is negative 16, plus 17 gives us 1, times negative 4 is negative 4, plus 4 is 0, which is good. So that means that we have the x plus 2 initially. We now have an x plus 4 factor that we can split this thing up into. And the other factor is now going to be this quotient, which is 1x squared plus 4x plus 1. This is kind of the end of the line on factoring. There's no numbers that multiply to 1 and add up to 4, so we're going to have to go to our quadratic formula for this quadratic part here. So I've got x equals negative b, that's negative 4, plus or minus the square root of the b value 4 squared, minus 4 times the a value 1 times the c value 1, all over 2 times the a value 1. Simplifying that, we have negative 4 plus or minus the square root of, let's see here, this is 16 minus 4, so that's going to be 12 inside there. And then we have 2 in the denominator. 12 I can split up into root 4 times root 3, so that's going to be 2 radical 3 if I square root that radical 4. And I'm going to simplify the rest of this in just a sec, but let me start writing my answers while I do that. So I've got, for this x plus 2, I've got x equals negative 2. Then next we've got x equals negative 4. And then we can simplify this. This is going to be negative 2 plus or minus just 1 radical 3. And that's a grand total of 1, 2, 3, 4 answers for our 4th degree polynomial. For this one, we want the complex zeros for this 3rd degree polynomial, along with the possible rational roots list. So for the list, which is going to help us get these complex zeros, we have factors of our constant 3 divided by factors of our lead coefficient 7. And these are all plus or minus factors. So we've got plus or minus 1 and 3. Those are the factors of 3. And then we're dividing that by the factors of 7, which are just 1 and 7. Let's make some fractions, individual fractions with each combination here. So we've got 1 and 3 both divided by 1. So that's just 1 and 3, plus or minus. Now we have 1 and 3 divided by 7. So that's 1 over 7 and 3 over 7. So these are the 8 total numbers that I might have to plug into this polynomial with my calculator to see if I can get a 0 out of all this stuff. So plugging some things in here, we'll start with 1. Now I could use the calculator on this, but this looks pretty straightforward just to plug in 1 and possibly negative 1. So let me just do this in my head here. Plugging 1 into this stuff, that's going to be 7 plus 5, which is 12, plus another 1 is 13, plus another 3 is going to be 16. So that's not 0. Let me plug negative 1 into all of this. So that's going to be negative 7 and positive 5, so that comes out to negative 2. Now we're subtracting a 1, so that's negative 3, plus a 3 gives us 0. I could have used the calculator, but with ones, sometimes easier to just do it in your head. So this is telling me that if I plug negative 1 in using synthetic division, I should be able to break this thing down a little bit further because I'm going to get a remainder of 0. It's going to let me factor this thing. So setting up my synthetic division, I've got my coefficient of 7, then 5, 1 for the x, and 3 for our constant. And our box number is going to be -1 because we know that's going to give us 0 for the remainder. So let me bring down this 7 here. Times -1 is -7. Plus 5 is -2. Times -1 is +2. Plus 1 is 3. Times -1 is -3. Plus 3 is, thankfully, 0. This tells me I can factor things a bit. So I can break my f of x up into x minus my box number, so x plus 1 then, times my quotient. This is going to be 7x squared, one exponent lower than the original started with, minus 2x plus 3 equals 0. And I might be able to factor this. I'm not really sure, but it probably is just going to be easier to use quadratic formula. So let me do negative b, that's -2, plus or minus the square root of b squared, so minus 2 squared, minus 4ac, so that's minus 4 times the a value 7, times the c value 3, all over 2 times the a value, which is again 7, so 2 times 7. Simplifying a bit, we have 4 on the outside there, or actually 2, -2 is 2. Plus or minus, we have 4 in here when we square the -2. But now we're subtracting, what is this? 4, let me just do this a little bit out of order. 7 times 3 is 21. 4 times 21 is 84. So we're doing 4 minus 84. That's a grand total of -80 inside there. And then we have a 14 in that denominator. Now, -80 I can break down a little further. I'm going to have to take an I out because I have a negative in there. I can also split 80 up into 16 times 5. So square rooting the 16 gives me 4 radical 5, and I have that I out there. So we have 2 plus or minus 4i radical 5 when all is done on that simplifying. I can still simplify a little bit more, but I'm going to wait for my final answer to do that. So going back here, I have an x value of -1 as one of my zeros because of this x plus 1 factor. And now I can simplify this quadratic piece here as simplifying everything by 2. I can call this 1 plus or minus 2i radical 5 all over 7. And that's 1, 2, 3 different answers because I have a cubic polynomial, so that's what we would expect.